Okay, so does anyone remember what page? I guess not, because we didn't have the pages yet. We talked about arc length, right? Okay. Okay, we're just waiting on a couple more people. Hopefully they show up. Here's one. Anyone have any questions for me while we're waiting on a couple people to show up? Okay, I'm gonna assume everyone else is going to show up soon. So I'm gonna share with you guys the teacher notes that I put up. And you guys can let me know if you prefer the whiteboard over the notes. Oh, let's colon. How much is your lawyer per hour? Okay. So I know we went over this or started this on Monday, but I went ahead and I was able to get the printouts from school. So I just wanted to give you guys the, I guess, neater version of what we did on Monday. It's okay if you don't want to write these definitions again. I apologize. Standard position should be in this blank. I just saw it on my section. Let me know if you do want me to slow down on any of this, but I know that we already discussed most of it on Monday. There's some different examples. So if you decide to go back on your own and look at it, there are some different examples. For instance, this one is new. But before we keep going, the question is, do you guys want the whiteboard, or do you guys prefer the screen share? Someone give me opinions. I'll do either, obviously. Or we can do a combination of both.
I think a combination of both is the best. Like it's
Combination.
easier to, yeah, because it's easier to see here like what the question is and stuff like that.
Okay.
And you can't write out new stuff on it.
Right, I cannot write out new stuff on it. So I think what I'll do. Okay, so I think what I'm gonna do is, if you guys can see, so I'm gonna stop the screen share real quick because I do have to take a snapshot of the attendance real quick. What I'm gonna do is, if you guys can pull up your Canvas, I'll make sure that you have the empty notes. Okay, 9.2.20, enter. And then I was hoping to wait till everyone got in, but I just wanted to let you guys know that I went ahead and I extended the 7.1 homework to be due tonight, because I try really hard to always do my if I give you guys homework, then I want to also do it, and I just didn't get to it yet. So I just extended it until this evening. And then hopefully we'll get through sections 1 and finish 1 and get into section 2 today. Why is it not on here? Let me get it for you guys real quick. Okay, so while I'm getting that over there, I know we went ahead and did arc length yesterday. So what I want you guys to do while I'm looking for the blank notes, I want you guys to do this problem. Okay. Okay, so there's 3 short problems. Only one of them is on your actual blank notes, but you guys can go ahead and do them while can you all see it? Let me turn the light on real quick.
I can't really see the full board.
Okay, let me try to find myself again. What part of it's missing? Is that way better?
So a little bit of the top.
The top. Like that?
Oh yeah, that's good.
Okay.
And then the first number there on the last line, that's a 3, right?
Yeah. Yeah, that's a 3.
Cool. Thank you.
Mm-hmm. Okay. So all 3 sections are up. All 3 blank sections are up. I don't have the teacher notes up for 2 or 3 yet, only for 1. I'll put up 2 and possibly 3 if we get there today. Homework 1 and homework 2, I believe, are due for this evening. Homework 2, though, should be pretty easy. I thought the notes were easier than the notes for 1. All right, so since we're still kind of recapping, what did you guys get for these sub questions, I guess we'll call them? And what formula did you use? Anybody who wants to answer?
The formula is S equals R theta, I think.
So S equals R theta, but then because you want an angle given in radians, how do you have to rewrite this?
Theta has to be over 360. Yeah.
S divided by R equals theta.
Right. There we go.
Oh.
Yeah. So if we just wanted to get so that theta is by itself. Okay. So and remember in the arc length theorem, theta is already in radians. So we would only have to change it if it wanted degrees. But it does tell us that we want to stay within radians, so we don't actually have to do anything except the simple division. So if we kind of label these A, B, and C, and like I said on the teacher notes, I only have for 2 miles, but I wanted you guys to have some stuff to do while I threw those files up. So what are we doing for the first one? How are we getting theta?
It's 5/2, right?
5/2. If you wanted to write it as 1.5 radians, you can. It's really up to you. I would take it either way. I would assume the program would too. So if that's the case, then what's the next one gonna be?
5/3.
And the last one is just 5/4. Okay. So if you guys can pull open your canvas and then select the blank copy of the notes. So it's the one that's it says live session, and that's where you're also gonna find your recordings. And I did Monday's recording. I just have to upload it. Okay. And someone remind me, did we leave off on arc length or did we do the conversions as well? We did conversions too, right? Did we do all the conversions or did we have to stop partway?
Then we stopped partway.
Okay. Okay, so I assume then that we did all of the degrees to radians. We just have to do radians to degrees now. Yeah, cool. Okay, so if we're gonna convert from degrees to radians or vice versa, okay. And I do apologize because if we were in class, you guys would all be coming to the board. But unfortunately, we're not in class. So I'm the only one that can write on the board. Okay. Somebody walk me through the first one. What do we have to do? If we are converting from radians to degrees, what do we multiply by? Does anybody remember?
180 over pi.
Very good. Okay. So you can kind of do them all at once, right? In a way. We would just have to multiply all of them by 180 over pi. So what do you notice about the last one?
It doesn't have pi.
It doesn't have pi, so pi is not going to cancel out. That doesn't mean we did it wrong. That just means that we have to include pi whenever we do it in the calculator. So when you work all of these out, who has the first answer?
Is A 108?
What kind of 108?
Oh, degrees.
Right, degrees, but also remember, look at the.
Oh, negative. Sorry, I didn't see
That's
that.
okay. If it's negative for radians, you want to make sure you keep the negative for the degree and vice versa.
Yeah.
Somebody tell me what B is. Somebody different.
I got 60 degrees.
Good job. And I'll box them just so you guys know. Okay. And C.
Or 80 degrees.
Perfect. All right. And the last one. I would round to 2 decimal places.
Would it be 114.6? Sorry.
Yep. Okay. All right. Would anyone benefit from the unit circle being put up on the canvas? I don't know if there's one up there, but if there isn't one up there,
Yes.
yeah? Okay. I'll make sure that I find you guys one. All right, any questions on conversions? Okay. Make sure that you pay attention to the program. If they ask you for degrees and your answer is in radians, it will mark it wrong, and vice versa. But don't worry if you're pulling your hair out. I probably will also be pulling my hair out because, like I said, if I give my students homework and quizzes, then I'm also doing them. Okay, so there's a conversion table. I'm not going to go through it with you. I think you guys can all figure it out. What I will tell you is that the difference between theta radians and theta approximate radians is the theta radians, they just want the regular, they want you to include pi. So I won't do all of them, but so they have theta degrees, they have theta radians, and then they have theta approximate radians. And the difference is, so obviously the first one, they're all zeros. But then they give you the degrees, and you have to go through and figure out the radians and the approximations. So 30 degrees is obviously pi over 6. 45 is pi over 4. 60 is pi over 3. And then down here, they just want you to take pi and divide it by 6. So 0.52, 0.79, 1.04, and then you guys can finish the rest. And if you need to look it up, you can look it up in the teacher notes. Does that make sense though? The approximations are not going to have the pi symbol with it. And then the next thing we're going to do is we're going to create the unit circle. I'm not going to draw it all the way out, but what I will do is I will go through and we can figure out the radians for the major radians for each quadrant, if that will help you. And for whatever reason, they don't have the degrees for the unit circle. They only have the radians. I think I'm just going to put it up on Canvas for you. One, two, three. All right. You guys have any questions on this stuff? Are we good to go? Cool. Okay. I would definitely say make sure you do your homeworks. If not ahead of time, definitely the morning before class. So then that way we all get everything super quick. All right. So the next thing we're going to talk about is finding the area of a sector of a circle. So that's when, and again, I apologize for not having any true way of drawing any better than this. Okay. So what we're talking about here is the area of the whole piece there. I'm not going to color it in because that would just take too long. So if we let the central angle be the entire circle, or 2 pi radians, what is the area of this sector which represents the area of the whole circle? How do you think we would find it?
We take the ratio between radians and the entire circle.
So we're going to use the area of a sector theorem, and that's when we take, essentially we're taking the area of the circle and dividing it by theta. So what do you notice happens? What cancels out?
Pi.
Pi. So what we have to add in there though is theta. So it's so this is a proportion. Okay. So basically it works down to area equals r squared theta over 2. And that's what you care about. And we have an example when you guys are ready. So the notes, I don't know if you guys got if anyone got the actual book, but if you wanted to, if you're able to go through the notes, that's basically what I do is I go through the notes. So if you were to ever miss class, it literally takes it straight from the textbook. So if we had an example, I think it's 10. Yep. If we had a sector of the circle has a radius of 5. So a sector has r of 5 feet. And it's formed with a theta of 40 degrees. And you want to round your answer to 2 decimal places. How are you going to do it? What are you going to do? What do you guys think? What do you think the first thing is that you have to do?
At 46 or 40?
So 40.
Do you have to put the theta from degrees to radians?
You sure do. So let's do that first. So theta is going to become what? If we have 40 degrees, what are we going to multiply it by?
180 over pi?
If we do 180 over pi, are the degrees canceling?
Oh,
So you want to
It's
flip
pi
that.
over 180.
Very good. So the little degrees cancel. So then theta becomes what? You can round it to 2 decimal places if you need to.
122. Wait, I forgot to do something.
Oh, sugar cane. Guys, I just got marker all over my pants. Don't worry, it would have happened in class too. Where's my marker? All right, well, my marker just went MIA. That's not good. All right, you'll have to let me know if you can see the next color or not. Okay, so how are we finishing this part?
Okay, so for radians, it is 0.0044.
How'd you do it? Talk me through it.
40 times 3.14. Yeah, 40 times 3.141592, and then divide that by 180. Oh wow, I must have typed it in. All right, it's 0.7 rounded.
Okay.
Yeah.
Yep. So you can either do, and like I said, I'm using a different color here, guys, so let me know that you can see it. So you can either do 0.7 radians, or if you wanted to leave the pi in there, it's 2 pi over 9 radians.
Yeah.
My suggestion is if you try it using the decimal and the program tells you got the answer wrong, go back and do it with the actual keeping the pi, and then round at the very end. But I think it'll give you the same answer either way. So now if we wanted to plug our theta into our equation, what are we gonna do?
So it would be 5 feet or 25 feet times 0.7 over 2, which is 2. So that's going to be 8.75.
Very good.
So then that's going to be your 8.75 feet squared.
Perfect. Okay. Always remember your units. Your units will be very important. If you wouldn't have been paying attention to your units, you would not have known or remembered potentially that you needed to do the conversion. Okay.
Wait, so it's 25 feet?
You mean why is it 25 feet here?
Yeah.
Because it's r squared.
Okay.
Yep.
Thank you.
You're welcome. Okay. So I'm going to give the definitions of the rest, because we really only have one question or one example left, and then we can move on to 7.2. And I think we'll be able to get through that a little bit quicker. So does everybody have this one down? Good? Cool. And like I said, I record everything, so it will be up on Canvas. I guess if you really wanted to follow me on YouTube, you could, but you would be pretty bored. All I put up is math videos. Okay, So the next thing we're going to work on is linear speed of an object traveling in a circular motion. So the first thing we need to recall is that distance equals rate times time. Okay. And another way to write that is that speed is equal to distance divided by time. Okay. So when we translate this into dealing with a circle, V is defined as your linear speed. T stays T, and then we all know that the arc length is now S. So that's your first definition. And this is for linear speed. Linear speed of a circle. Okay. Angular speed, right? Because circles deal with angles. That's defined as a Greek letter that I can never remember how to pronounce. Over theta over t. And then the last one you kind of need to remember is if we combine some stuff together, which is in more detail in your book, but basically for the sake of what we need to work with, we're going to have V equal to rate times the angular speed. So you want to write all three of those down. So then we're going to do our last example. I'm probably going to have to erase partway through, but we're going to write down the key points. So the distance from the axis to a location on Earth is 40 degrees north latitude, and that distance is 3,333.5 miles. So it looks, and this is a flat representation. I am not going to sit here and try to draw a sphere right now. Okay. So we have 40 degrees, and then the distance is equal to 3,333.5 miles. And is there any other information? No. So what is representing our R right now, our radius?
Half of the diameter.
Remember, this isn't diameter though. That's distance.
Oh,
So if that helps you out. So it's not That isn't representing diameter. It's just representing from this point in the core to.
Oh. Okay, so then that
some
would be the
point.
radius.
Yep.
Yeah.
Okay, so if this is our radius, okay, what do we have to remember about the Earth? Because keep in mind, we're trying to figure out the linear speed of an object, which I guess is what this is, the linear speed.
It makes one rotation a year.
One rotation a year. So how long does it take to do one revolution?
It was
Uh,
24 hours.
24 hours. So because it
yeah.
takes 24 hours for one revolution, we can figure out what our, I'm gonna call it a W. If you guys figure, like, if you want, I'll try to remember the real name, but the angular velocity, so this W is going to equal 2 times pi divided by 24. And then that's going to end up getting us radians per hour once we do this. So what do we get for the radians per hour? If you take 2 times pi divided by 24.
Do you want to like a decimal approximation, or like it could be pi 12?
I would do the decimal and I would do it to 4 spaces.
I got 0.26. I mean 0.2618.
Very good. Okay, so that is your radians per hour. So then to get the linear velocity at 40 degrees latitude, we want to do V times R. So we're inserting into this one. So what are we going to do? We're going to take our radius, which is 3,333.5 miles, times 0.2618 radians per hour. And what do we get? I'm going to round the nearest mile. So what do you get? Did you get it? So for time's sake, you should get 794 miles per hour. Okay, so chapter 2 should be a little bit quicker. It's dealing with your more typical, what I think is typical geometry, trig. And just so I know, the blue versus the red, does the color make a difference on your end?
Yeah, red is better.
Red is better? Okay. All right, so you can get the blank copy of the notes for 7.2 on Canvas if you want to pull them open so you can follow along with me, or you can just write the notes down paper and pencil style with or without following that guide. So now we're going to look at right triangle trigonometry. So your typical, and we're going to pretend that's a right triangle because there's a little square there, so it says so. We have our theta, we have our A, we have our B, and we have our C. And just for the sake of review, your C is representing what?
Hypotenuse.
Yep. And then A and B then are your what?
Legs.
Your legs. Very good. So, I am not going to write out all of the words, but we know that sine theta is equal to what?
Opposite over hypotenuse. Cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent.
Good job.
And then the other ones, the inverse of sine, cosine, or sorry, cosecant is just the inverse of that.
Mm-hmm. Okay, and I apologize if any of my A's look like 9s or my B's look like 6s. Okay. So, B, C, secant theta, yep. What did I write down wrong? This should be an A. Sorry, guys. B, A, and then cotangent of theta is AB. Okay, so obviously that is something that you're going to want to memorize. If you want to memorize the words versus the letters, that's fine with me. If you prefer the letters over the words, also fine with me. Just make sure that whenever you have your drawing, you pay attention to what they're giving you. So obviously not all the drawings are going to be the same. You might have to relabel, do that in your head. So let's, I guess let me first ask, how comfortable and confident is everyone with the trig functions? Do we need to go over a whole example of how to find these from a triangle, or are we good to go on to the next example?
Go over an example.
Go over an example? Okay, no problem. So the example we have here is it says find the value of each of the 6 trig functions for angle theta, given that the side adjacent the angle has the length of 12 and the side opposite the angle has the length of 5. So we're going to have to end up using Pythagorean theorem, right? Okay. And we'll just use this triangle because we already have it drawn out. So how are we going to find what C is?
Isn't it a squared plus b squared equals c squared?
Yep. So a squared plus b squared. So then with the numbers we were given, we're going to have 12 squared plus 5 squared, which means c it is the square root of 169. So c is equal to 13. Okay, so we'll plug that in up here. And then all you have to do is go through and find your trig functions based on that triangle. I'm gonna give you guys a second to do it while I write these down. So eventually you'll get so good that you'll be able to just rattle these off. So if sine is b over c, b is 5, our hypotenuse is c, so what's sine?
5/13.
Very good. All right, somebody new, what's cosine then?
Say 12 over,
Go ahead.
12 over 5.
12 over. What was your hypotenuse for that? 12 over what?
Oh, sorry, 13.
Mm-hmm. Okay, good job. Okay, so then that leaves someone new for tangent.
That's 5/12.
Very good. All right, so then the inverses are a little bit easier because now that you have this side, you're just going to do the reciprocals, right? So someone else new, do the cosecant.
It would be 13 over 5.
Very good. Someone else? Someone new? Come on.
2/12.
Very good. Oh. Okay, and cotangent. Someone else. See, you guys aren't going to like these ones because there's so many parts to it. I can get almost everybody to answer a question. So the cotangent is just the reciprocal of the tangent, right? Okay, so we're going to get 12 over 5. Any questions on that? Okay. So the next example gives us a sine and a cosine, and we have to figure out the remaining 4 using definitions. So will it help if I keep these up here? Yes, no, maybe? I'll keep them up for right now. I should have just A, B, C. And where's my theta? Okay. All right, so for example 2, they give you sine theta is equal to the square root of 10 over 10, and then the cosine of theta is equal to 3 square root of 10 over 10. And they want you to find tangent theta, and then once you find tangent theta, they want you to find cotangent of theta, and then cosecant and secant. Okay, who has an approach? Which one do you want to do first?
So tangent is root 10 over 3 times root 10.
Right. So
So-
it's a complex fraction, which means we're going to have to basically multiply by the reciprocal, right?
Yeah.
So then we'll have root 10 over 10 times 10 over 3 root 10. What do you notice about the 10s? They cancel,
I cancel.
and root 10 cancels. So then we just have a tangent of 1/3, right?
Oh, yeah. Yeah,
Okay.
I could have simplified that.
Yep. And you have to remember to do that. If you don't do that, you're going to end up getting the answer wrong.
Hmm.
So then that just makes cotangent equal to what?
3.
3. Very good. Okay, so those two are done right away. Okay. And that's the same approach I also took. So good job on that. Okay, so cosecant, remember cosecant is going to be the what? It's going to be
Secant, the reciprocal of sine.
very good. It's going to be the reciprocal of sine. So it's going to be 1 over radical 10 over 10, but we can't leave it like that. So then it becomes 10 over radical 10, but can we leave it like that? We have to do what?
We have to multiply by the root of 10.
Right, we have to rationalize the denominator. Okay. So then it just works out to what? Radical 10, right? Because this cancels and this cancels. So then it's 10 radical 10 with 10 underneath. And those cancel. All right, so the secant is very similar, except it's the reciprocal of cosine. And if we follow through this same process, for the sake of time, we're going to get radical 10 over 3. All right. Any questions on that? Where is my eraser? I found it. Okay. Are we good to move on to the next example? Yeah? Cool. Okay. So does anyone remember or recall what the fundamental Pythagorean identity is called? Or not called. What is it? Anyone want to take a guess?
Do you want like the formulas where like the sine and the cosine they equal to 1 or something?
Yes. So it's sine squared theta plus cosine squared theta equals 1. So that's a trig identity that you're going to want to definitely remember. If you got, did anyone get the actual physical textbook? No? Okay, some of you. If you flip to the back cover of your physical textbook, you'll see an entire list of the trig identities. I will find a PDF and put it up on Canvas for you, for those of you who just have the electronic version. So we can start out with our sine squared cosine squared equal to 1, and we can get to a couple of other identities. So if we take this and we divide it by sine theta, sine squared theta, we're going to end up with another identity. So we're going to divide each piece by sine squared theta. Okay, what do you notice with the first part? What's it become? Sine squared theta over sine squared theta is just going to become what?
1.
1. Very good. What do you know about cosine over sine? What does that become? So if sine over cosine is tangent, cosine over sine is what?
Cotangent.
Cotangent.
Very good. So it's going to be cotangent squared theta equals what's 1 over sine?
Cosecant.
Okay. So cosecant squared theta. So this is another whole identity, okay? If you want to see the definition of the next one, you would just take cosine squared. And what would you end up getting? It's kind of like the reverse of this one.
Is it tangent squared theta?
Mm-hmm.
Plus 1?
Mm-hmm.
And maybe not cosecant, secant?
Very good. Very good. Okay. So if you want to work that out, you can. Okay, and we're going to go over a couple of examples. Okay, so if we have 1 over cosecant squared, oh, nope. Yeah, cosecant squared 35 degrees plus cosine squared 35 degrees. What's your first thing you want to do? What can you kind of see? So Trig's all about translating things. So cosine squared is probably a good thing to keep, right? So you would want to find a way to rewrite 1 over cosecant squared. So how do you think you would rewrite that? What's an option you can do? If you think back to what your reciprocals are.
So it would be sine squared over, well, yeah, it would be the same thing except cosecant would be sine.
Very good. And then what do you notice about this statement? What does this statement equal?
1, I believe.
Yep. So that's your overall answer for this one. It is just 1. Okay. So slightly the same case if we have cosine of pi over 3 and sine of pi over 3 minus the cotangent of pi over 3. What do you notice? What can you do?
That will also equal 1.
Will it equal 1? Well, what's cosine over sine give us?
Tangent.
Cotangent.
Cotangent, right?
Oh, cotangent. My bad.
Right. So since it gives you cotangent, what do you notice you have as your answer?
Cotangent.
Right, but what's your overall answer? If you have cotangent pi over 3 minus cotangent pi over 3, you just have what?
0.
0. Yep. So that overall answer there is 0.
Sorry, for A, could you just move down? I can't see the bottom of the board.
That's okay.
Thank you.
Does that help?
Yep, thank you.
Okay. Okay. So since we only have 4 minutes left, or I guess 5, what I would like to do is I want you guys, as soon as I put up the teacher notes for section 7.2, you only really have, we didn't get to page 228 and we didn't get to page 229. So what I would like you to do is go through the teacher notes. If you can understand them, then just go ahead and write them down. If you have questions on them, what I want you to do is send me a quick email, because what I can do is I can just record myself teaching you that last page and a half, and I'll put it up on the Canvas. So then you guys can definitely get, I think, section 7.1. If you need to go back over that, you can complete that while you're tonight, and then you can do 7.2 tonight as well. And then that means on Monday, well, nope, not Monday because we don't have class. On Wednesday, we will do 7.3 and maybe 7.4. Sound good? Okay, definitely shoot me an email if you need me to send you a video of the rest of 7.2, okay? But if you're good with it, then we're just gonna say we're good. Anyone have any questions for me? I did change some of the due dates to try and give you guys some more time, but the problem became as I got closer to the end of the course, we basically ran out of time. So we're gonna have to kind of play things by ear, and if we need to move due dates as we go over things, we'll move due dates. But for right now, I tried to move them kind of based on what I see in my head, but maybe we'll be able to do more sections in one class period, and then that would help us catch up a little bit. All right. If you guys don't have any questions, I hope you all enjoy your holiday weekend, and I will see you all on Wednesday.